All right. Good morning, everybody, to another Monday Mornings with Masterwall with Grant and Brian. I am Brian.
I am Grant.
We are welcoming you to another week, Monday morning with education, entertainment, and engagement. Hope you guys had a great weekend on Mother's Day. Happy Mother's Day to all the mothers that are out there. And today we have a special guest with us. We're going to work a little bit different today. As always, you have questions or comments, please email Grant or myself. We are more than willing to kind of talk about anything on this show as possible when it comes to exterior envelopes, EIFS, stucco, and the like. One thing I was going to mention as well is talking about swag. I mean, Grant, we've talked about giving away swag stuff each time. So in the near future, I'm going to be putting together, I haven't even proposed this to Grant yet, but I'm going to be putting together some kind of a thing where when we mentioned a word, if somebody can mention and we talk about that word that's used, do you email back that word that was used, whatever the hot word of the day is, we will then send you some swag stuff, just a way to keep people engaged and kind of involved in the conversation.
Swag like this hat, Brian?
Like the hat, like sweatshirts or t-shirts or bags. I mean, whatever we have, even a little puppy bulldog stuffed animal that we have, which everybody loves at these trade shows. Today's different. We have Laverene Dalgleish with ABAA. He's the executive director there. We're going to work this a little different. We are going to start off more interview style. I'm going to stop sharing my screen specifically. And so allow you guys to really chime in whenever you want. You don't have to have your video on. You can keep it off for as long as you want, and that's fine. Come in if you want to ask a question. Raise your hand would probably be the best, and we can call you out. So at least that there's some kind of system to this whole thing. But rather than going right into a presentation of sorts, there was enough questions that I had in my interaction with Laverne last week that we felt like we could go through this as a regular straight up interview style within regards to this. Now, Laverne comes with a plethora of background in exterior envelopes. Now, he is the executive director of ABAA, Air Barriers Association of Americas. He also sits on the chair of multiple committees of ISO, TC 163, ULC, S700 committee for thermal performance and built environment. He also travels the North America area, educating the builders, owners, and designers on the benefits of effective and working air barrier systems. And that to me is one of the biggest reasons why I wanted him and the ABA to get involved in this, because we in the stucco and EIFS world deal with this every single day. He also is one of the, I think you're founder or president of Building Professionals, right, Laverne? Which offers a number of value-added services to the clients that they have in areas such as standards and developments, code consulting, and product and system research. And so this morning, I welcome you, Laverne, to the show. Hope everything is doing well. You're in Winnipeg, aren't you?
Yes, I am.
That's awesome. And why don't we start off speaking specifically about codes and standards? That was one of the things that, at least for me, was what keyed me into calling and reaching out to you, was the short 1-minute video that you had put out there with the ABAA talking about codes and standards, and how we were talking about last week, code is the minimal requirement needed for a job. And that is not always the best way to look at things when they point to the code. But what is the difference between the codes, the standards, and what's your take on kind of that overall view of things?
So let's start with standards. Standards are simply, let's do everything exactly the same way. So the main standards that we see out there is material specifications. And so you'll have a list of material properties and their test methods and minimum or maximum performance rates in those. And one thing I'd just like to point out there, though, if you read the material specification, and I don't care who develops it, whether it's ASTM, ULC, ASHRAE, whatever it might be, there's always a little clause in there, and it says that this standard is not to be used for end use. It is for comparison and conformity control only. And where that's important is that if you take a particular value, doesn't matter whether it's an R value, whether it's water vapor transmission rate, whether it's air leakage or whatever it might be, that is for that material at a certain set atmospheres. If you change atmospheres, which changes hour by hour on the job site, it's going to be different.
Mm.
Then you get into installation standards and application standards and a whole bunch of things. But it's basically, and we use standards every day. Like, you could not live without standards. Even trying to put paper in your photocopier, there's a standard for that, and it works. And the list goes on and on. Now, building codes are put in there for supposedly health and safety. And they've always been the minimum that you can do. In fact, one of the comments out there, codes are the minimum that you can do without going to jail. And there's a bit of truth to that. Obviously, if you have structural problems and you have fatalities, you could end up literally going to jail. But a lot of people look at the codes as being the end all. If I built a code, I got a really good quality building, and that's far from the reality. The other problem that you have with code is there's a lot of conflicts. So if you go to this section of code, you should do this, but building science says that's wrong. And if you go to another section, it's different. So code might be a good place as a starting point, and it's obviously something you got to meet. But if you're going to design your building just to meet code, I would sell it really quickly.
Interesting. You know, you said there at the end as a starting point, and how many times I'm sure the applicators that are online right now watching this, they will appreciate that, because so many people, what does code say? What does code say? That's great, but that's the starting point. It's not where I want to be, especially as an applicator, let's say, or as a manufacturer. For us, we want to be sometimes better than that, right? We want to make sure that we're higher than that. I thought it was interesting. Grant, I watched a little bit of his presentation last week, and I had seen in another one that Roy had done with the ABAA talking about the peanut butter test. Can you explain a little bit about what the peanut butter test is?
I can. So what I hear a lot of times, even from manufacturers, is, well, why is ABBA getting involved? Because ABBA is right now the only organization that evaluates air and water resistant barriers. You can't go any other place. And that's good and that's bad at the same time. But one of my points was to people that said, well, why are you doing with anything except the air leakage rate of the material? That's all you should be concerned about. You're the Air Barrier Association, leave everything up to the manufacturers. And my response in those days is, well, if the only thing we're going to look at is the air leakage rate of materials, how permeable it is, then peanut butter and Jell-O would work. And I didn't have anything to back it up. It was just a thought that I had. I was able to browbeat a person that sat beside me in a codes meetings for a whole day. And if you've ever attended code meetings, they can be the most boring meeting you've ever been at. And so I actually have a test that's an ASTM E2178, which is the air permeance of building materials. And I tested peanut butter. I'm actually, if I can do this right, I'm going to go quickly to a slide that I can show you.
Yeah, absolutely. Definitely do that. I mean, this is one of those crazy things I think is just in the guts of understanding all this stuff, to think, hey, I can use peanut butter and it would work.
Well, the other thing, I thought this was going to be my retirement plan, because it's very environmentally friendly for most of the United States. It's grown within 100 yards of your building. It's easily transportable, all the rest of the stuff. So here's my peanut butter sandwich. Right. And here's a test. So in an ASTM E2178, you want a meter by meter specimen. Whoops. And if it's fluid applied, you need to put it on substrate. So this was actually installed onto a CMU, medium density. Wow. We did 20 mils, and it's craft. I don't know about Skippy and Peter Pan, and it's smooth, so I don't know about Crunchy. But I always say, well, okay, how do you think it did? Well, it actually does pretty darn good. So in metric, it's 0.02 is the maximum air leakage. That's equal to 0.004 cubic feet per square foot at a pressure difference 1.57. And this is 1/10 of that. So you would say, well, hey, it meets all the requirements. And actually, I'd like to point out, here's a good example. It meets code requirements.
Wow.
So if you're only building to code, go out and buy a bunch of peanut butter. The other issue that I'd like to bring out is, here's two materials. This one's from the ABBA website. You can go to the ABBA website and you can see all the air leakage from the materials. And there's about 3 or 4 that are basically the same air leakage rate. Now, this is a fluid-applied air and water resistive barrier, and this is my peanut butter sandwich. And the issue becomes, you know, really, which do you want on your wall? So I think that's a good example of why you want to build above codes. The other thing we've got to keep in mind is how long do we want the building around? And a lot of times I'll sit in meetings where they're a pre-construction meeting or whatever it is, or even a standards meeting. Well, you know, 20 years, 30 years is what we have to design for and so on. And if you're MIT or any university, well, let's build for 100 years. I always ask the people, how long are you in your house? And I'm going to use myself as an example. This is my second house. It was about 20 years old when I bought it. I've been here for 20 years, 23 years. So we're getting close to 50 years, which a lot of times we talk about is a long time. I want to sell that house sometime in the future, and I'm sure the person that buys it wants to live in there for another 50 years. Mm-hmm. So that's the other thing. Codes are not designed for longevity. They're health and safety and what protects you at the time of construction. And it's mainly the drawings that get you approval by the code. Yeah. Most of them don't even get into the quality of workmanship. And so we got to go past the codes into, we want a building that actually is going to perform, and we want a building that's going to be around for 50 years, 75 years, 100 years, whatever it might be.
Yeah. You know, it's funny to go into, so why does this even matter sometimes? Like you were kind of hitting on there, the air, like, just focus on the air. In the sense you talked about the amount of water, and I was talking about this in a presentation not long ago, where those penetrations, right? We talk about with the liquid applied water barrier systems, like those penetrations that come through a pipe or something that's coming out of the wall. Why do we need to make sure that's sealed? Is not so much of wind-driven rain coming through a little hole that's a pinhole somewhere there, but because of the air. And I don't know, you know, I know I talk about 70% of litigation in the construction industry is water-based. But that doesn't mean that the water entered in by itself. It's coming through the air. So the calculations that you had shared with me last week regarding that, what was that?
Well, I'm going to pull that slide up, but
I don't see your slides, by the way. I don't know what the piece was or why the share screen wasn't there, but.
I wonder, maybe trying to see if I need to do something on my side here. Probably do. It says share screen. Let's try that.
Yeah, hit that one. There it is. Perfect. It'll come up here probably. Okay. It's nothing there now, but it'll probably then once you show it.
Anything showing up here?
No. Yep, there it is. So all your slides are showing. Yep.
Okay. So you got to actually go back to the history of air barriers and keep it really short. We started in the 40s to figure out why water is getting into our walls, and University of Minnesota did a lot of work, and we started using building paper. Then in the 60s and 70s, we started to throw a lot of insulation into buildings, and we're having huge water problems. And so we started looking at vapor barriers, and we put vapor barriers in walls, and we still had water problems. So specifically in the 80s, there was a lot of work done as to why is the water coming in there. And so the first air barrier code was the National Building Code of Canada in 1990, where there's a requirement to have an air barrier in your building. And that's important because in 1990, you could not talk about energy savings. It was strictly a health and safety code. So the only thing that you could pull on there was degradation of the walls, mold, mildew, corrosion, whatever it is. So one of the things Abbott did is they had an air barrier energy calculator, because we wanted to show people that you could save energy by putting air barriers in and so on. And we got discussing that, and we said, well, if we know how much air is leaking in and out of the building envelope, and we know the temperature conditions and relative humidity hour by hour on the outside, and we know what it is on the inside, can't we calculate how much moisture is going through that building envelope? And it turns out it's actually pretty simple. This is a slide I like to show because we always think a lot of times air barriers in the north because it's cold and it's going to get condensation. But the number one place you'd ever want to put an air barrier is Miami or Houston. And what you're seeing is a typical building, which leaks about about 4 to 5 cubic feet per square foot that's out there. And here's one that is retrofitted with 0.25 liters per second. So you can see Chicago's colder than Miami, Winnipeg's colder than Chicago, and so on. So the amount of moisture that's going through those buildings go down. So the code for a long time said if you're down south, you don't need to do anything. But we're now realizing that's wrong. And you can go on the ABBA website. I did a presentation for the Building Enclosure Council in Portland. So I pulled up one of theirs and I went through. You can choose where you want. United States, you can choose. There's 16 archetypes out there. You can choose which ones. And these archetypes, by the way, are what is used to determine energy savings for the International Conservation Code and ASHRAE 90.1. So I used, this is metric, 7.5 liters. I went down to a half a liter. Energy cost is what's used in the code. You can change those. You go through a calculation process. And here's the part that you want to look at, ELA, equivalent leakage area. So with the base case, there is about 140 square foot hole, or square foot hole, yeah. And when we retrofitted down, it went down to 9. Now that still seems pretty big, but you got to go back to the archetype, and this archetype is 210,000 square feet. Here's the part that you really want to look at, which is down here. So without an air barrier, you've got 650,000 gallons of water that goes through the building envelope every year. Now that doesn't automatically say it's going to stay there. It means it's passing through the building envelope, either in or out. And some of it's going to condensate depending on how you've constructed. Yeah. Now, if you tighten it up, you went down to 91,000 gallons, and that still sounds like a tremendous amount of water, but at least that's a heck of a lot better than 650,000. So that's the key thing that we're trying to get people to recognize is why would you put an air barrier in? It's not just energy. It's not just so it makes a building look good. It's actually a protection of the building. And as you say, the biggest insurance claims that's out there is the fact that it's water damage. Yeah. And the presentation that was at EMA from that insurance consultant, what I took away from his presentation, and look out, both our rates for insurance is going to go through the roof. And for a lot of contractors in that, we may be going back into the days where you can't even get insurance. Yeah. Yeah. The insurance is a big one. Hey, I got Chip, go ahead and unmute yourself if you want. I know you have a question out there. If you want to show your face, you can. You don't have to.
Hey, Laverne. So this is Chip Pizzignaro with DuPont. How are you?
Good. How are you doing, Chip?
Good, good. Actually, my subject, even though most people know DuPont from a Tyvek perspective, my subject is more on your recent LinkedIn post about the fact that IBC has not paid much attention to the fact that air causes water damage, as Brian just brought up in this recent conversation. I was also really kind of surprised at the blowback that you got a little bit from some people talking about that topic, but I love it. We talk a lot about that issue, the fact that if air gets into your wall, it can create moisture. Do you think that IBC is going to take air as a question from a construction point and not from an energy point at some point?
I sure hope so. It's actually, in hindsight, it's too bad that air barriers were put into the IECC to start with, because that's, again, putting everybody towards it's energy only. We should have started with the IBC and the IRC. Now, Teresa Weston did put a code change proposal in the vapor barrier side of things so that we are starting to make a connection. So for the 2021 code, hopefully that will stay in there and at least be a start. And on the next round, we can have a better connection to moisture problems in walls. Mm. And we see this time and time again. And, you know, after 20 years of starting in the year 2000 and now we're in 2020, the amount of misinformation and wrong information out there is unbelievable. I was on a call even with some of our members, and an architect says, oh, we gotta worry about the water vapor transmission rate of the materials and so on.
Uh-oh. I think we lost him, Grant. I don't know, Laverne. It's all right, Grant. Go ahead. What did you have?
Well, I was just going to say, those of us that call on architects and hear from general contractors regularly, I think the biggest misconception maybe is what is a vapor barrier. They call everything a vapor barrier. So kind of how Laverne educates people on the difference between a vapor barrier versus just an air and water resistant barrier that's vapor permeable. But Laverne's frozen, so I don't know if he can answer.
Yeah, there he comes now.
Hey, Laverne, did you hear that question?
In my whatever happened here, but I lost the whole question.
That's right. Go ahead. Go ahead. Actually, yeah, I think that's good. And I think that's the tie into everything that we're talking about. Go ahead. Ask it again, Grant.
Okay. Yeah. Those of us that call on architects on a regular basis, or even general contractors, they refer to everything as a vapor barrier. That's their go-to word when talking about air and water resistant barriers. So from your education perspective, how do you differentiate that when you're educating people? You know, what's a vapor barrier? What's just a vapor permeable barrier that's an air barrier, water resistant barrier? Just kind of talk through that language briefly, if you can, for the group.
Well, that's a whole day seminar. You got to use adult education.
Notice I said briefly, because I knew where that could go.
So in adult education principles, you have to de-learn the person from what they've got in from whatever reason, and then you teach them what is right. And to a certain extent, we have to go through that. And part of our problem is that there's a lot of what you can call vapor barriers or vapor retarders and different classes of vapor retarders that are also air barriers. And the most common one I see is in residential construction where a polyethylene foam, anywhere from 3 to 6 mils, everybody knows it's a vapor barrier, and that's not, nobody disagrees with that. But then they install it as an air barrier. And when we get a call, whether it's from a building official or anybody, and they start to talk about, it's got to be free of holes, it's got to be lapped, it's got to be sealed, I go, hang on, I thought we were talking about vapor barriers. Vapor barriers, you can have holes in them, they don't have to be lapped. Read the code, there's no requirements for installation. And we can again get into a whole bunch of physics as to why that is. So that's what we have to do. And I see it, there's also an ASTM standard for the installation of vapor barriers below slabs to keep the moisture from coming up. And if you read the installation guide, it's all about sealing the membrane. It has nothing to do with water vapor transmission. And the other thing is there's, Roy and I worked on a couple of articles, we call it to perm or not to perm. And one of the things I try and do is get people to understand what are we actually talking about. So 1 perm or 0.1 perms, whatever you want to use in your area, is 57 nanograms if you switch it over into metric. And it's a little bit easier to understand. And that's a billionth of a gram. Nanograms are 57 billionths of a gram. So a penny weighs about 2.2. So think of a penny, cut it in half, cut it into a billion pieces, and then take 57. That's the type of, now that's per square meter per second per Pascal and all the rest of that stuff. But we had Oak Ridge actually calculate out what that means. So in a square meter, which is about a stud cavity, 16 inches by 96 inches in that range, you're going to, if you're 1 perm, you're going to get about 16 ounces of water. If you're 0.1 perms, you're going to get about 6 ounces of water, and so on and so forth. Now, when you think of that going over a year, that's not a lot of water. The other thing that people don't understand, and I'm going to try and share my screen again, is, okay. I think it's in this one, is how the water vapor transmission rate is calculated. There's what I want. And there's a lot of confusion in this too. So, and the code uses dry cup, or the desiccant method. And I think that's absolutely wrong, has nothing to do. But you got to go back again to what it always says. This is not for end use performance, it's for comparison materials. And to compare materials, you need exactly the same atmosphere. So if you can see my screen, you have one on the left-hand side, which is an automatic machine. The one on the right-hand side is the old way of doing it. And the one in the middle is your specimen. And in your specimen holder there, in the bottom, you either put water or you put a desiccant. So you have 100% relative humidity or 0%. You put your material on top of it, and then you put it in an oven that's 23 degrees C, or about 73 degrees Fahrenheit, and 50% relative humidity. So you go from 0 to 50, or you go from 100 to 50. So roughly 25% relative humidity, if you want to look at it that way, and 75. How often is a cavity wall 73 degrees Fahrenheit and 25% relative humidity? I'm going to say very seldom. What you have to keep in mind there too is that as soon as you change that, you're going to change the water vapor transmission rate. So on the next slide here, and I'll try and make it even bigger. So I just went to the ABBA website because every material we list, both dry cup and wet cup, we require that you do both testing. Now the first one here, if I get this done right, there we go. So this is exactly the same material, dry cup and wet cup. So the one that had the smallest difference started out with, and these are nanograms, this is not perms. 5 nanograms roughly is going to be less than 0.1 perms, just slightly less. And there was a variance of 4% between one that had the least amount of difference between the two. The mean, and we had about 76 different materials there. So this would be the result of about the 36th one. It started out in dry cup 121.26, which is going to be about 2 perms. And then when you did the wet cup, exactly the same material under exactly the same circumstances, we're up over to 800. So 558% increase. And then the one that was unbelievable went when you tested it dry cup at 4.3, it went up to 1,805, 42,000% difference. And then I simply took a look at all materials, and the least water vapor transmission rate that we had of any material was 0.75 in dry cup. Now these are not the same materials in this one, and 5.5. And then we went up to 943 to 2026. The whole point of this slide is to show that there's a tremendous difference depending on where your material. And these are the standard curves. And this is the difference between adsorption and desorption. And it is AD, it's not absorption, AD, it's AD, which is water vapor. And depending on the relative humidity, which is always tied to temperature, you're going to get a different number no matter what you do. And I don't think anybody really realizes that out there. And that's one of the things that we want to get into when we're dealing with architects and engineers. This is basic physics. This is building science.
Yeah.
Unfortunately, we don't teach building science at university. Even the architects and engineers that are a member of ABBA and so on. And we've worked with other organizations like BTEC and so on. And we've worked for years to try to get building science as a part of a course for any engineer or architect. And it's an uphill battle, and I'm not sure if we're ever going to get there. But
well,
it's basic physics and should be applied everywhere.
Yeah, and you mentioned that, and I think that's one of the huge pieces for the point of anybody who's on watching this or here now or not, whether it's a distributor, an applicator, a sales rep for a distributor, or for a manufacturer, or an architect and owner, is that stucco and EIFS world, the world that we live in, is exterior cladding of things is not just a commodity issue, right? It is a science behind this. It is very technical. I mean, yes, okay, the color, whatever color you want. This morning I had somebody talking about your white's not too white. It needs to be whiter. And it's like, okay, like that's just the aesthetic of it all. But behind the scenes, there is a lot of science and detail into this. It's not just a commodity thing. You've got to know what's going on in your building. with that, I know we only have a minute or so left till 11 where we can keep going after that, but talk briefly about the QAP and then the new CABS program that you have and why, because I do know that there is, and I know we may run over a little bit now, but I think this is important because there have been times I've been on a job where a QAP program, so quality assurance program that you guys have, an applicator might say, oh, they're just looking for money. They put the ABAA QAP program in there and it's just a money grab. But there's more to it because we need to know that this is what is not going to occur. Water's not going to come through because of the air barrier piece and why it's so important.
So, yeah, and part of the problem with air barriers is you can't see air leakage. And so you don't know whether you've done a good job unless you test it. The other way to look at it for QAP, I'm just trying to find the slide here, is that it's a risk management program. So if there's a risk in construction, how do you fix it type of thing? And so what ABBA did, and we did this right from the very start, is that we went and we took a look at why things are happening, why are problems out there. And this is a program that I started work on when I started my work with the International Standards Organization when ISO 9000 was first coming out, and now we have a bunch of other standards. But to me, it was very logical because a lot of times people say, well, we just need an inspector. If we have an inspector comes out, and there's third-party inspectors on almost every project, and that third-party inspector is there to make sure things are done right. But the problem is he's inspecting after it's done. Mm-hmm. And what I propose and what's been working really, really good is, why would you inspect something unless you set a standard for it? If there's no standard, then it's my opinion or the inspector's opinion. And there's lots of fights in the construction industry. Well, I did it right. No, you didn't. Yes, I did. And so that's the baseline. And then you got to have proper material evaluation. So everybody has to test to the same way so that you can compare materials. You got to get the trade contractor involved because he's the guy that signs the contract and is legally responsible for the work. Now, our definition of contractor is the legal entity. So it's not the workers. This is a touchstone or a keystone, whatever you want to call it, the training and certification of the actual workers. So going back to the inspector, he goes out on the job site. Why would he expect things are done right if you've never trained the workers to do it? Mm-hmm. I remember being down in South Carolina and we're talking about all the moisture problems in buildings down there. And I says, well, how's the labor here? Is it qualified, or like, is there a community college or a trade school that people can go and get the information from? And they go, well, not really. We go to 7-Eleven at 6 a.m. in the morning and we pick up our workers for the day. And I'm like, then why do you expect to have any proper qualifications? And then continual improvement. The one advantage we have as ABBA is we get daily work records and audit reports from all over the United States. I'll give a really quick example. We had a case in Ohio where it was a fluid applied in it was a pinhole. And of course, the first thing you do is you point your finger at the manufacturer. And so their answer to it was put another layer over it and that'll fix it up. Well, the more layers you put on, the more pinholing you got. Mm-hmm. To make this story short is that as we saw the same type of thing happening to every fluid applied membrane, irregardless of the manufacturer, we traced it down to the manufacturer of CMU in that area was putting something in the block that reacted with everybody's material.
Wow.
Because the standard for CMU is structural. It has nothing to do, you can put anything you want in there. And so that was something that all of a sudden we're able to now track it down better and so on. So
interesting.
Quality assurance program is there to help you. And we get a lot of misinformation again. We're there to have the project
Laverne,
go
let me cut
on
in.
time and on budget.
Let me cut in real quick because I do have Brian. Brian, go ahead and unmute yourself. And honestly, don't even know, Brian, where are you, if you're still on there, Stork? Let me see if you come on. Brian, can you hear us?
Can you hear me?
Yeah, go ahead. He had a question, or he was going to say, use me as his example. Laverne, I have no idea if this is a good example or a bad example or what. But Brian, go ahead. Let's see where this goes.
Oh, I always make Laverne nervous. So I'm
Okay.
the current chair of the Air Barrier Association,
Okay.
and I got involved with them back in about 2004. We had a project which specified using the ABA QAP. At the time, I was a QA manager for a large CM. And as you mentioned, my first initial knee-jerk reaction was, this is a money grab.
Mm.
What is this about? I can tell you, after running that program, I then subbed out, made sure that the sub who performed the air vapor barrier material installation was invited to bid on all the rest of our projects. The quality of the workmanship was outstanding. The fact that you had the checks and balances, and we had a third-party auditor coming to the site to look at the installation, and not just to point out what was wrong, but to try to help us figure out where we had some issues, especially in the early 2000s when this was very new to the industry, was second to none. And it was just awesome. So I truly am one of the poster children for the belief of this. I was a QA/QC manager, right? That was my world. And to see them come in with this program, I went from a guy who was saying, hey, what is this, right? To somebody who is now the chair of the association.
Yeah.
I don't know how much stronger you can think about a program than that.
So Brian, stay on there for a second, and Laverne, maybe tie that into, I think, look, in the world that I live in, as much as it may not be air barriers that are every day selling out there with contractors that I even know that are doing things, but the new opportunity, right? For, let's say, people that I deal with, EIFS and stucco guys that are doing a liquid applied air and water barrier, but this creates a new opportunity for them, right? Like I've seen drywall guys become EIFS and stucco guys because on a hotel, they're doing the inside and the outside of a wall. In this way, somebody like you, Brian, you may be looking at that now and saying, man, I can do the air and water barrier. I can continue doing EIFS. And some of my EIFS and stucco guys could be doing the flip by saying, hey, I can start doing this, become a QAP, and then tie that into maybe Laverne talking about the cabs. I know Roy, if he ever listens to this, I will mention that he is the first ever in North America to have the cabs program thing that's out there. And he has a unique, apparently, ID number for it. So we can ask him about that and let him love and dwell on his success of passing that test. But the new, and correct me if I'm wrong, the Certified Air Barrier Specialist program that you guys are going to be rolling out, correct?
Correct. So a couple of things there. One of the things we're starting to realize, most people anyway, is that we've got to look at assemblies and not just materials. So that gets into the EIFS guy becoming a water resistant barrier and so on. And all those things got to work together. So if you have one contractor that's doing all those different layers, you're going to have a much better building. So the Certified Air Barrier Specialist came about because what we saw was representatives from manufacturers being out there, and a lot of times they're the first face that the design professional sees. And we had concerns that there was mixed messages, not quite clear messages, wrong messages all over the place. And so the board wanted to develop a program where we would bring, or have the opportunity to bring people up to at least a minimum educational level on the basic building science, how air barriers work, water resistant barriers, and so on and so forth. So that program actually is available now as far as a certified, and it's certified in accordance with 17024, which is really important. But the board decided that what we needed is a study guide, a training program, whatever you want to call it, so to allow people to educate themselves first. No sense of going to a certification program if you don't know your stuff and you fail the test, you're not farther ahead. So that will be out late summer, and the manual you'll be able to get, you can study for it, wherever it is, and it's also to bring in your normal knowledge that you have being out in the industry, and then you can become certified air barrier specialist, and you'd be allowed to put CADS on your business cards, letterhead, those type of things. It's an individual certification. Certification is always to people. So that we're looking forward to being able to work with people and raise the level of education of the whole building enclosure.
Absolutely. Grant, did you have anything else? I know we're 11:10 just about, so I'm going to end it soon, but are there any other questions out there? We should be good. Laverne, I want to thank you. I mean, go ahead, Grant.
Maybe one quick one.
Yeah.
Kind of revolves around EIFS a little bit, but a lot of manufacturers have moved to higher perm air and water barrier, fluid applied barriers. So, obviously we're just typically dealing with a 1 pound density EPS. What's your opinion? Most manufacturers range somewhere between 10 perms and 30 perms, 30 being on the high end. And I'll just say Masterwall is on the high end, full disclosure. What's your opinion on the permeability of barriers behind EIFS on being 10 to 30? Do you have an opinion one way or the other there?
Well, you learn in building science that you always answer a question with it depends. And there is absolutely no question right across the United States, design professionals are saying we need higher permeance on our materials because we need to let buildings dry. And again, that's absolutely true. What bothers me a bit, and I'm a little bit concerned in some cases, is that some of the people that say that don't understand what that means. As a quick thing, we had a manufacturer go to state of California, which had a minimum 10 perm rating and wanted to raise it up to 50, which happened to be their material. And so when we discussed that with the state of California, we said, it's a good idea, but what you have to keep in mind is, although we can produce one-way materials, we don't because they're expensive. So if you have 30 perm material, it's going to, the water vapor transmission weight is going to go both ways. So Southern California, you get a rainstorm, the sun comes out, you're going to have a horrendous moisture drive. But again, that's on a single material. The advantage EIFS has is you have, your base coat and your finish coat, you have your expanded polystyrene, then you have your air and water resistant barrier and so on. And the issue there is by having the insulation as continuous insulation on the outside, that changes the world in most buildings. So the short answer is it's probably really good, but you still got to go back and take a look at where you're building your building and how are you building? What are all the parts that's going into your whole wall?
Thank you.
Yeah, I think that's the most interesting thing is even have a conversation this morning with somebody on delegated design and design build and a process that looks like, and especially on the envelope, having one customer, having the owner take on a contractor to say, we want you to involve the design build part of this and delegate that to you so that it's all unique and wrapped. And I appreciate your time. Thank you so much to everybody. I'm going to cut the video recording